Hello everyone, welcome to the series where we are covering quantitative aptitude questions from previous year UPSC CSAT papers. In this series we are covering previous year questions from 2016 to 2025. Right. In the previous sessions we covered questions on number system from previous year papers 2016 to 2022. And in this session we will cover questions on number system from CSAT paper 2023. So let's begin with the questions. Question number 1 is what is the remainder when 85 into 87 into 89 into 91 into 95 into 96 is divided by 100. Okay. So here we need to find what will be the remainder when this product is divided by 100. Right. The given product is 85 into 87 into 89 into 91 into 95 now and 96. Now let's divide this number by 100. Okay, now we can cancel out numbers from numerator and denominator by common terms. Let's cancel out 85 with 5, we get 17 here and we get 20 here. Again we can cancel out it with 5, we get 4 here and we get 19 here. Right. Similarly we can cancel out 4 with 4, we get 1 here and we get 24 here. Now we see that this number is completely divisible by 100. That means remainder is 0. So right answer is A here. Now let's move to question number 2. What is the unit digit in the expansion of 57,242 raised to power 9 into 7 into 5 into 3 into 1? Right. Now here we need to find unit digit in the expansion of the number, given number. Okay. And the given number is 57242 raised to power 9 into 7 into 5 into 3 into 1. We can simplify the exponent and it will become 572 raised to power 42 raised to power. If we multiply all these terms, it will be 945. Right. Now the unit digit in the expansion of this number will depend on the unit digit in the base, that is 2, and its power, that is 945. Now we can reduce this problem to find the unit digit in the expansion of 2 raised to power 945. Okay. Now let's see what is the cyclic pattern of 2 raised to power n. Okay. Now when n is equal to 1, unit digit will be 2, and when n is equal to 2, units digit will be 4. Similarly, when n is equal to 3, unit digit will be 8, and when n is equal to 4, units digit will be 6, and when n is equal to 5, units digit will be 2. Now we see here that after n is equal to 4, units digit starts repeating. Okay. Now here we can say that cyclic pattern of 2 raised to power n is 4. Right. Now again, if we divide 945 by 4, okay, we get 140. Yes, we get 236 as quotient and 1 as remainder. Now we can write 2 raised to power 945 as 2 raised to power 4 into 236 into 2 raised to power 1. Now these are 236 complete cycles of 2 raised to power 4. That means here the unit digit will be 6, and here unit digit will be 2. Again, if we multiply both these digits, we get a unit digit as 2. So right answer is 2 here. That is A. Now let's move to question number 3. If A, B, C and D, E, F are both 3-digit numbers such that A, B, C, D, E, F are distinct non-zero digits such that A, B, C plus D, E, F is equal to 1111, then what is the value of A plus B plus C plus D plus E plus F? Now in this question, we need to find what is the sum of all the digits in both these numbers, right? Now what we are given? We are given that when we add A, B, C and D, E, F, we get sum 1, 1, 1, 1, right? Now we get 1 here only if C plus F is equal to 11, because we cannot have 0 here, because all the digits are distinct and non-zero, so we cannot have 0 here. We must have C plus F is equal to 11. Neither we can have C plus F as 21 or 31, okay, because maximum sum of two digits, right, is 18. So only one possibility is there, that C plus F will be 11, right? Now when C plus F is 11, we get a carry over here. Now again we get B plus E plus 1 as 11. So that means B plus E is 10. Similarly, again we get carry here, and again we get A plus D plus this carry as 11. So A plus D again it is 10. Now if we add all these digits, that is 10 plus 10 plus 11, that makes 31. So sum of all these digits will be 31. So answer is D here. Now let's move to question number 4. D is a 3-digit number such that the ratio of the number to the sum of its digit is least. What is the difference between the digit at the hundreds place and the digit at units place of the number D, right? Now suppose D is the A, B, C is the given 3-digit number. Now we are given that A, B, C and the ratio of it sum of its digits is minimum, right? Now we need to find the difference between A and C, right? Now we are given that the ratio of A, B, C and A plus B plus C is minimum, or we can say it is least, right? So let's see. We can write this number A, B, C as in the expanded form. It will be 100A plus 10B plus C divided by A plus B plus C. Now when we increase B by 1, numerator is increased by 10 and denominator is increased by 1. Okay, and this ratio, say this is R, suppose this is R, this ratio will be decreased, right? Now if we increase A by 1, numerator will be increased by 1, denominator will be increased by 1, and R will further be decreased. Okay, now for this ratio to be minimum, we must have B and C as large as possible. B and C as large as possible, right? And the largest values of B and C can be 9, 9. Similarly, we should have value of A as small as possible, that is 1. So the given number can be 1, 9 and 9, right? Now we are required to find the difference between the digit at hundreds place and the digit at units place, and the difference between the two digits will be 8, right? So answer is C here. Let's move to question number 5. Now question number 5 is, 3 of the 5 positive integers P, Q, R, S, T are even and 2 of them are odd, not necessarily in order. Consider the following. Statement 1 is P plus Q plus R minus S minus T is definitely even. And second statement is 2 plus 2P plus Q plus 2R minus 2S plus T is definitely odd. Now we need to find which of these statements are correct. Right. Now to solve this question, we use the concept of parity of numbers. Right. And that is, when we add an even number with an even number, we get an even number. And when we subtract an even number from an even number, even then we get an even number. Similarly, if we add two odd numbers, we get an even number. And similarly, if we add an odd number from an odd number, we again get an even number. Okay. Now, if we add even number and an odd number, then we get an odd number. And if we subtract an odd number from an even number, we get an odd number. Right? Now, let's come back to the statements. Statement 1 is P plus Q plus R minus S minus T is definitely even. Right? Now in the question we are given that 3 numbers of these 5 numbers, 3 numbers are even. That means we can group these 3 numbers together, right? By moving plus and minus signs, we can group these 3 even numbers like even, okay, and we can group 2 odd numbers together, right? Now plus minus sign can be any. Now result of these even numbers will be even number, and result of these odd number will be even number. Further, if we add or subtract these two even numbers, result will be always even number. So this statement 1 is always correct. Now let's see statement 2. Here we have 2P plus Q plus 2r minus 2s plus t is odd. Okay, now let's see. First let's take 2 as common. Now we have p plus r, sorry, minus 2, sorry, minus s. Okay, p plus r minus s, then plus we have q plus t. Okay, now this expression gives us an even number because we are multiplying it by 2. So here result will be even number. Now if q is even and t is an odd number, okay, then in that case this expression will give an odd number. Okay, and further if we add or subtract these two numbers which are odd and even number, then we will get an odd number. But if q is even and t is also even, in that case stay 2p plus r minus s plus q plus t, here this is even, and here since both these numbers are even, it will also be an even number. Now if we further add or subtract these two even numbers, we will get an even number. Now according to statement 1, this expression always gives an odd number, but we can also get an even number. So this statement is not always correct or not always give an odd number, right? So here answer is 1 only. Let's move to question number 6. Consider the following in respect of prime number p and composite number c. Here we are given two numbers p and c, where p is a prime number and c is a composite number. Now we are given three statements and we need to find which of these statements is correct. Okay, now here whenever we are given that a statement that something is can be true or something can be something, in that case we try to find a case where we can prove that statement correct, right? Now here we can randomly take the values of p and c and we will try to prove that this statement is true. Okay, now suppose p is equal to, now let's see statement 1, p is equal to 11, and since p is a prime number and c is a composite number, let's suppose it is 9. Now p plus c will be 20 and p minus c will be 11 minus 9, it will be 2, and p plus c divided by p minus c will be 20 upon 2, it will be 10, and 10 is an even number, so statement 1 is correct. Now let's see statement 2. Suppose P is equal to 3 and C is equal to 9. Now in this case 2P plus C will be 2 into 3 plus 9. It will be 6 plus 9 is equal to 15, and 15 is an odd number. So second statement is also correct. Now let's see statement 3. PC can be odd. Okay. Now suppose P is equal to 3 and C is equal to 15. Right. Now P into C will be 13 into 15 is equal to 45, which is an odd number. So statement 3 is also correct. Okay. So here answer will be 1, 2 and 3. Right. Now let's see question number 7. Now question number 7 is, how many distinct 8-digit numbers can be formed by rearranging the digits of the number 1, 1, 2, 2, 3, 3, 4, 4 such that odd digits occupy odd positions and even digits occupy even positions? Now in this 8-digit number there are 4 even positions and 4 odd positions. Okay, and the even numbers are 2, 2, 4, 4, right, and odd numbers are 1, 1, 3, 3, right. Now 4 even digits can be arranged in 4 even positions in 4 factorial divided by 2 in in the now question number 7 is, how many distinct 8-digit numbers can be formed by rearranging the digits of the number 1, 1, 2, 2, 3, 3, 4, 4 such that odd digits occupy odd positions and even digits occupy even positions. Right. Now the given 8-digit number has 8 positions. Right. 4 are even positions and 4 odd positions. Right. And even digits are, right, and odd digits are 1, 1, 3, 3, right. Now we can arrange these four even digits in, now we can arrange 4 even digits in 4 even positions in how many ways? That is 4 factorial on 2 factorial into 2 factorial, and it will be equal to 4 into 3, 2, 1 divided by 2 into 2, we cancel out 2 here, and similarly we cancel out 4 with 2, we get 2 here, and it is equal to 6. Similarly, we can arrange 4 odd digits at 4 odd positions in 6 ways. Total arrangements will be 6 into 6 is equal to 36. So there will be 36 such numbers. So right answer is C here. Let's move to question number 8. For any choices of values of x, y, z, the 6-digit number of the form x, y, z, x, y, z is divisible by. Now the given number is x, y, z, x, y, z. Now we can also write this number as 1001 into x, y, z. Now if we observe this number, then the factors of 1001 are 7, 11 and 13. So this number will always be divisible by 7, 11 and 13. So right answer is D here. Let's move to question number 9. Let x be a positive integer such that 7x plus 96 is divisible by x. How many values of x are possible? Right. Now here we need to find all values of x for which this number is divisible. Right. Now let's see. The given number is 7x plus 96. Okay. Now this part is always divisible by x because x is a factor of this part, right? We can also say that this is a multiple of x. Now how many values of x are there that such that this number is divisible by x depends on how many factors of 96 are there. Now the factors of 96 are 1 into 96, then we can have 2 into 48 or 3 into, right? Similarly we can have 4 into 24, then we can have 6 into 16, and again we can have 8 into 12. So how many factors are there, or we can say how many values are there, how many numbers are there by which this number will be divisible? These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So there are 12 such numbers or values of x by which this number will be completely divisible. Right? So answer is C here. Now let's see question number 10. If P, Q, R and S are distinct single digit positive integers, then what is the greatest value of P plus Q into R plus S? Now we are required to find the largest value of P plus Q into R plus S. Right? The largest value of this expression will be when we have largest value for P, Q, R and S. But since all these are distinct digits, right, we can assume P is 9 and Q is 8, right? Then R can be 7 and S is 6, right? Only then this expression will have the largest value. So now let's calculate. P plus Q will be 9 plus 8, and let's assume R plus S is 7 plus 6, and it will be 17 into 13, and it will be 221. So right answer is D here. Okay. So that's all for today. We covered some questions on number system from UPSC CSAT paper 2023. If you find the session helpful, please like, share, subscribe and support our channel. Thank you.